Concrete slabs are among the most common structural components in civil engineering, providing horizontal surfaces such as floors, pavements, and bridge decks. They are designed to distribute applied loads safely to supporting elements such as beams, columns, or the ground. The analysis and design of concrete slabs require understanding their behavior under various loading and boundary conditions, which are often nonlinear and complex. Traditional analytical approaches, such as yield line theory and elastic plate theory, offer simplified solutions but are limited in capturing nonlinear effects such as cracking, reinforcement interaction, and material degradation. Therefore, numerical simulation techniques, particularly finite element analysis, (EFEA), have become indispensable in modern structural engineering. The main purpose of concrete slab simulation is to predict the structural response of slabs under realistic service and ultimate loads. This includes evaluating stress distributions, crack initiation and propagation, deflection patterns, and failure mechanisms. Through simulation, engineers can assess the structural safety, durability, and serviceability of slabs before physical testing or construction. Simulation also facilitates parametric studies, such as varying slab thickness, reinforcement ratios, or boundary conditions, to optimize performance and material efficiency. It enables the visualization of slab behavior under various load combinations, providing valuable insight for design improvement. Abaqus is one of the most powerful tools for concrete structure simulation due to its advanced material modeling capabilities. The concrete slab package within Abaqus allows engineers to perform detailed simulations using both continuum damage mechanics, CDM, and plasticity-based concrete models. Abaqus provides built-in concrete models that account for cracking and tension and crushing and compression, stiffness degradation after damage initiation, concrete-steel interaction via embedded reinforcement or cohesive elements, time-dependent effects such as creep and shrinkage. Through FEA simulation, engineers can obtain detailed results such as load deflection curves and crack patterns, stress and strain distributions across slab depth, failure modes including punching shear and flexural cracking, effectiveness of reinforcement layouts and material improvements. This package offers a complete course on concrete slab simulation using Abaqus software. The tutorials include 20 detailed and independent projects, each supported by research-based models. Every project provides step-by-step instructions through English language videos, CAE/INP files, and supplementary research papers. The course covers various concrete slab types like simple slabs, RC slabs, FRP reinforced slabs, composite slabs, foam reinforced slabs, UHPC slab, UHPFRC reinforced slabs, as well as advanced material models such as CDP and JH2. These are applied to a wide range of simulations including 3- and 4-point bending, PET foam core slabs, composite slab with new joint, CONW EP air blast, CEL explosion, SPH explosion, low and high impact, fire steel concrete composite slabs, and the course includes 20 practical and comprehensive tutorials that you can find each model in the description page. FEM provides a powerful and flexible framework for realistically analyzing and simulating concrete structures. By capturing material nonlinearity, cracking behavior, and complex geometries, engineers can predict performance, optimize design, and ensure safety and reliability. Concrete slab analysis and simulation represent a crucial part of structural engineering research and design. By using advanced software like Abaqus, engineers can accurately model complex slab behaviors, reduce experimental costs, and improve design reliability. The integration of FEA results into design processes allows for the creation of more efficient, safe, and sustainable structures, aligning with modern engineering standards and sustainability goals. This package is ideal for civil engineering students, geotechnical specialists, and researchers. With lifetime access to downloadable resources, you can learn at your own pace anytime and anywhere. I hope you have a good understanding of this package, but for more questions and details on each section, please visit our website, Engineering Downloads, or email us at info@engineeringdownloads.com.